I know in my experience it's not that very straightforward for everyone, because seems like you don't like simple. So one of the other way to solve for this one that make it easier is just to plug in the values. Yeah, I know that. So let's say we can make it slower by calculate the kinetic final, right? So let's calculate this one first. Let's calculate this one first before we solve for that. Yeah, because I just learned in my experience this is easier for you. So let's solve for this one. This one will be 1/2 mv final square, right? Okay, so that should be, let's plug in the value here. And then the mass, we got it from here, 2 kilograms. And then the final is 25 meter per second square. Yeah, so now what do we have? We have 1/2 times 2 times 25 square, that should be 625 Newton, right? Oops, sorry, my bad. Yep, that should be in joule. Yep, because joule is the unit of energy. So you can see here if you got, let me move this one down here a little bit. Okay, if you got 1 kilograms times with meter square over second square, or that should be in joule, right? Can you see that? Because if you just add another meter to the Newton, that if you just multiply newtons with another meter, that would be meter square, right? That should be the joule. Makes sense, right? Yep. So the unit is each joule. Okay. So we got the final, we got the total. Can we find the initial kinetic energy? Is our logic here? Yes, right? Okay, so let's solve for the kinetic energy. Let's solve for this one. Solve for initial kinetic energy. Then we will have the kinetic energy will equals to, so we want to move this one to this side, right? Because we want it to be positive. So we need to move the work to this side, just like we did before. So we got, that would be kinetic final, final kinetic energy subtracted by the work total. Okay, so let's just plug in the values. One should be like 625 joule minus. Okay, be careful. We have to keep the minus here and just copy the whole thing, into this one. Okay, let me paste it here. Okay, so that's it. And you see now it's a minus minus, so that becomes a plus, right? So it turns out that the initial kinetic energy is greater, which makes sense, right? Because it should be greater than the final one, because this is the amount that has been lost. Okay, lost. So we have this one is 925 joule. Okay, now we got the kinetic energy. Then let's get to the last step, because we know that kinetic energy initial equals to 1/2 u squared. So then now we solve for u from this one. Then we will get u equals to twice of the kinetic energy divided by the mass and then square root of it. So then just plug in the values. Twice times 925 joule divided by the mass to be 2 kilograms. And then what do we have in the end? Let's just do it together. Oh yeah, then square root. Then we got it's about 30.44, I guess. What is the unit? Meter per second, right? Okay, so this is the final answer. Okay, so that's good. So after we done, let's just check if it's meet with the reality. Um, this one, it should be higher than this one, right? And it makes sense, right? Because if it's move upward like this, the gravity try to pull it down, so we'll slow it down. That's why the work is in negative values, and which makes sense, right? hmm So, but I could guess that if you need to throw a rock like 2 kilograms, and it travel that fast, it means that it takes a lot of energy. You see, a lot of energy. So you really need to have some muscle to do this. Okay, so then yes, we done the first question A. Thank you for have sticking with me until this now, and I hope that you get this one through. Okay, just let me know if you have any question. Thank you. See you soon.